Awesome. Well, thanks everyone. Appreciate that. We're super excited to have you. Thank you for presenting tonight, and we'll give it off to you. Give it up for Miriah.
Hi. This was connected 5 seconds ago, so I'll probably have to connect again. Oh no, I just have to press the button.
3960.
Thank you. But yeah, I work at NAV. I started there back in February. It was my first job out of college. I did physics, so I have a physics background, a little bit of Java, not enough to say I'm a Java developer because I'm not. So Go is my first language. I love Go. And I now switched over to data science, which means my life is in Python, which is sad. Not because Python's bad, just because I have no idea what I'm doing in Python. I know what I'm doing in Go, but luckily I still get I get to maintain my old projects quite a bit, so Go for life. Why isn't it press and play? Come on, stupid thing. Oh, look, there's all of that. Oh, and I have a dog. He's the cutest dog in the world. And he likes to code with me, sit on my lap. So, yeah. I wanted to talk a little bit today about the use cases for Go in big data, both data engineering and data science. I think, in my personal opinion, there is no better language than Go for handling data at a large scale. And just to start out, I just wanted to talk about the two different use cases, right? So we have data engineering and data science. Both deal with big data. Both have to deal with a lot of just blankets of information and different layers, and they have to get it from one place to another and do things with it. And everybody's using it. Everybody needs more data. Everybody wants to use their data in a better way. Everybody wants to learn from their data. Data is the way the world works. So companies want data engineers. If you went on Indeed and looked for a machine learning engineer or data engineer, you'd find a whole bunch of companies hiring, and you'd be like, I didn't think those companies had data teams, because they probably don't. But they're trying to get there. So I have this little graph right here on the side, which is a really good kind of division of where the skills lie. Data scientists, generally speaking, do all of the hard math stuff, less programming. They have to do whatever they need to do to implement their machine learning algorithms, their AI stuff, manipulate their data, get it from one place to another. They do a lot of SQL queries and manipulations on there. But their strength tends to lie in understanding what the heck the algorithm means and why there are so many formulas in a deep neural network and what each of them do. Whereas your data engineer deals with a variety of complex systems, knows how the systems work together, how they connect, how they each deal with the data, how everything's distributed, how the data is layered or versioned, and basically anything else that makes the data solid and get from one place to another. So the reason I think Go is so amazing for handling data is, first off, the standard library is built around data. We want to type everything we want to use it. We can build our own data pipelines natively just using Go routines and Go channels. We handle the data, set it to one place, and get it from one way to another just with simple Go routines. We can handle JSON, handle CSVs, handle XML, handle SQL, store it, manage it, manipulate it, any kind of ETL you want to do, which is a lot of what data engineers do, you can do just with the standard library. A lot of big pipelining services are now building integrations in Go because they realize Go does it quicker and cheaper. So if you can get things working in Go on production, you gain a whole lot of bang for your buck. Apache actually isn't, so Apache Beam is in Go. Apache Arrow is not in Go yet, but if any of you are on the Gopher data science channel, one of the guys on there who is a physicist at CERN, is actually doing the Apache integration for Go. He does a lot of data contributions. Pachyderm does data pipelining. Apache Spark doesn't have Go. I heard they were working on Go. No, I know they have Go SDK for AWS. I just don't know which AWS services use Go. I know SageMaker does not use Go by default, but you can publish to S3 through Go. I do that all the time. That's basically all my job is right now. Gopher data, that's the next thing. Gopher data is a bunch of libraries that are used just for handling data. We'll get into that later. I'm using actually quite a bit of them now. Gonum is another library that is meant to handle the math around anything in machine learning. It does plots, it does vector manipulation, it does matrices, it does a whole bunch of stuff. Sajari has machine learning algorithms in it. Word2Vec is natural language processing. Regression is a linear regression. S.J. Whitworth GoLearn also has linear regression models. It has k-nearest neighbors. It also has decision trees on there. Gorgonia mainly is for implementing neural networks. And Go data frames is very similar to Panda data frames. So it lets us deal with the data in a different way. So as you can see, we have a lot of tools in Go that are at our disposal. It's just the problem right now is not a lot of people use them. They don't have a lot of adoption. Python with pandas and scikit-learn and NumPy and SciPy and what are the other things? TensorFlow. There is a TensorFlow in Go. I forgot to put that up there. It's just they have a lot more reputation, easier integration with the services, and so Go is kind of playing catch up, but we have all of the tools to get there. So I just think I have next as an example, right? Yeah. So I was just going to kind of walk through. Yeah. Any questions if you have them? Go ahead.
Quick question on that one thing you just were talking about. If you were starting from the ground up in data science and it was all up to you, could it be just done in Go?
If it was up to me, could it be done in Go? It depended on what model I wanted to use. If I was doing a simple model, yeah, I could do a linear regression at k-nearest neighbor. K-nearest neighbor is used for classification. So if I was doing a simple classification, I could write it up in Go. The struggle with implementing it, let me put it this way. In my opinion, Go is amazing to deploy to production, have your model running in production against whatever data set you want to use. But when you're first trying to test out which model you want to use, that's when Python's easier because you can just throw it up, it's scripted, and just test on the go. But that being said, it's very typical for people when they're testing models to turn to something like Octave or MATLAB that's more mathematically based for testing the models. So if you use MATLAB to figure out what model you want to use, then you can implement it and Go and deploy it to production without any issues. So I think it's completely possible to do it in Go.
I actually had a couple. So started out saying that there's a better language for handling data at a large scale than super data.
What's my version of big data and what's my version of large scale?
Yeah, I've seen some very relative measures.
So imagine that you have to take in, import, and ship out through a pipeline petabytes of data.
Yeah.
That's big data, right? So you're going to have at some point several CPUs or GPU if you're going to run machine learning on it. If you're just doing a pipeline to get it, do a nice ETL on it and get it into a database or however you're storing it. I think that Go will do it quickly and more efficiently than any other implementation I've seen. Now that being said, I don't need to update this. I have done a couple of implementations at my work using Python and Airflow and their DAGs. They have a beautiful UI, but it breaks all the time. And Go is generally speaking, once you get it up, it's pretty stable. You know, so you also get the stability factor from it. And so large scale, I would mean scalability to have it from different systems, however many servers you want.
So essentially you're measuring.
Yeah. 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 Do you have a second question, or was that?
I'll ask it later.
Okay. If you have any other questions, just let me know. I'm free to stop and talk about whatever. Come on. Here we go. So this demo I actually stole from Arden Labs. I did it at the machine learning workshop in Go, but I did make some changes. I submitted a PR to them, so I feel good about myself, even though the material is not mostly mine. So my binder is something really cool. It's actually not well known. I was the one that discovered it for my data science team, which made me feel super proud. So it basically allows you to deploy your notebook on a Jupyter hub. So Jupyter hosts the hub. They build a Docker image based on your GitHub library, and they spin it up for you. So you do have to do a little work to get the Go kernel running on it, but it's really nice because you can launch it right from GitHub, and anything that I can run on my machine, Jupyter hub will run there. So the only thing that stinks is you cannot make changes and commit them from my binder. So if you do want to make changes to your notebooks, you run locally. But as far as accessing and using, a notebook just for demonstrations like this, my binder is really nice. It lets anybody access and use and run your files and whatever you have working. This first example that they have here, I really like, because it kind of addresses that first point that the Go standard library can handle data by itself without needing any external dependencies. Has anybody used a Jupyter notebook? How familiar are we with Jupyter notebooks? Not really? Okay. So Jupyter notebooks are really nice to me. With my physics background, I'm really used to Mathematica notebooks, so the idea that I can do anything in a notebook is like joyful. But basically, a Jupyter notebook is its own internal kernel. So everything that has been run is stored and saved inside that notebook itself, and can be used for further. The code is divided up into cells, so each cell compiles and runs on its own. But whatever is run in this cell can be used by future cells. So it's really very common in data to mess around in this, because like I said, when you're searching for a model, you can make a change. If you don't like it, just change that same cell, run it again, and you see the output constantly. And if you like what you get, go to the next cell and keep using what you've done previously. So I have to run my imports or else nothing will work. This right here is just your basic importing of data from JSON into structs. Notice how all the structs are nice and nested and going and beautiful. So we'll run that too. And then here is where it actually reads it from the JSON file, and it should print it out here when it's done. 1, 2, 3, beautiful! Yay, JSON! As we can see, it's stored in just the way we want it to be. In the structs as they are. First data was our big, where was first data? Oh, first data is just unmarshaled. And here, we're going to put it into the JSON structs using a for loop. Where is the first data used again? Nope, they already did that. Oh, they did it right here. I missed it. Look, they unmarshaled it into the thing, and then first data just made it look pretty. So when they unmarshaled it, they put it into our emoji simulator, which was this one, the struct that holds all the other things. So all of the data should be held within our slice of JSON files. So if we take this, we run that, get some things in our emoji tuple, we should be able to, does this count? Oh, this is evaluating how many emojis are the same. No. Select where the emoji is greater than 3.5. So, oh, they're using natural language processing to evaluate. So they've converted everything into, it's very common to convert everything into a vector and compare it numerically. So by saying it's greater than 3.5, it's saying it all fits into the same category of bigger than something else. And we have 31 emojis that we considered to be similar or to be saying that they are in agreement. Things that, emojis that show agreement of something. So we should be able to write those out into, why didn't you print it out? I don't know. Oh, it only prints out there. That's weird. Okay. So that was that. There's also CSV is really common in data science. Everything's stored in a CSV if it's not stored in SQL. So I bring in, read out CSVs all the time. They don't tend to be passed through API endpoints. That just is, you know, usually for internal. But that being said, if you do use pandas, you do write from CSV all the time to get your data frame. So it's really good to know that Go can handle CSVs as they are, but I really like the way that data frames handle it. And look, they have data frames right here. I love data frames. And this is why. The reason I like data frames is simply because they tell you the type of everything, and then they have a header. So you know what everything is. This is a basic, this CSV holds all of the battles from Game of Thrones. It has the year they took place, the size of the armies, and where. We're currently not showing a region. But I'm pretty sure that it's summary. I think it's summary. Nope, it's describe. If you describe the data frame, it actually will tell you your basic average of the things. So we know that the mean year was around 300, a little bit less than, probably a couple months. You have the difference between each year is about 0.689. The earliest battle was the Battle of Mummers Ford. The latest battle was the Red Wing. And another cool thing about data frames is this nan right here. They actually have a nil built into data frames. And so if you have an int value or a float value or a string value, it'll print it out as nan, which is the data form version of nil. As we know, a lot of times Go doesn't have nils for your strings or your ints. The ints are 0, strings are just an empty string. But in data frames, they do throw that to nil. So that's really nice for a data science because we like things to be definitely nil. What was your question?
What library is this data frame?
So data frame, I was going to show you. This is one that I've actually used. It's called Goda. So they use here, they have Goda data frames, which have basically A series is a row, and the data frames is a set of rows, which gives you your matrix format. This is pretty nice. It reads in JSON and CSV, and it has, does it have the list of those functions? No, but it does have the Godoc somewhere. There we go. And like I said, it has the describe hidden somewhere. Oh, that's not there. It was right here.
It was there.
Did I miss it?
Yeah.
Oh, there it is. It has the describe in there. You can do a join on them, just like you would SQL. You can get the elements for it, so that lets you filter by row and column, which I've used and it's actually really nice. Again, throws me back to my physics days when I was dealing with MATLAB, because everything's an array in MATLAB. You can rename it. Subsets are nice. It lets you take out little parts of your data set, especially when you're cleaning your data. So this is actually pretty well built out, and it's good, been used well for most things. I've actually had some struggles with the reading from JSON. If it likes to read in an array of JSON objects that are only single nested. So if you have a multi-nested JSON objects, I would recommend just using the Go standard library and structs, as opposed to reading it in through data frames, because a data frame will read the first layer and basically ignore the rest of it. So, but for everything else, it gives you a lot of good insight into what your data is, and visibility is super important for data science. Knowing what your data is the first step to figuring out what to do with it. Oh, and this is the select. It lets you oh, it only, so when we did, oh, they had to describe below us. So when I wrote the describe, it just automatically gave me the name and year and size, but here, they actually put the parameters onto a select describe, so they were able to use year. They wanted to see the average years, the attacker size, and the defender size. We can see that because in a lot of the cases, that information was left blank, it was not able to calculate information. It was only able to do a min and a max, because you can't get a mean of nothing. So basically, if there is a nil value present, it doesn't calculate it. Another weakness of data frames, but I think that's just a lack of data. Reasons why data needs to be cleaned before it's used, because a lot of data can't be used, especially if there's values we know are wrong. This right here uses the GoNum plotting. I believe it's gonna get us some nice, what regions and frequencies? Did I skip something? I did. I skipped more. So this is the other thing that kind of stinks about notebooks, is because it has to use all of the cells. If you don't run a cell, the bottom ones below it may run, but if you skipped one that has information needed by a lower cell, then that's not, then you kind of break your program. It's good for demonstrations, kind of stinks for other things. So we need battles is unidentified. Oh, battles is right here. And this needs this one. And now it should work. Nope, records. Reasons to run everything. I have gone through these, but it's been a second, so. First battle, second battle. I just want to see the pretty pictures. Because the graphing in Go is actually really cool. I think plots are super powerful. That might be the physicist in me talking, but as soon as you visualize something, the better it is. So here we have a nice histogram. Oh, this is another cool thing about the Gopher notes, is it displays it below. You can, they do, I was watching a video. So on GitHub, if you go to Francesc Campoy's GitHub, he does have a library that prints graphs into the command line. So if you would rather use that instead of Gopher Notes wrapper into Jupyter Notes, you can print it into the command line instead. and have everything compiled that way. Which, you know, you wouldn't deploy a notebook, you would deploy a binary. So that gives you strength in writing your production models in what's going to be used. And then you could just, you know, see if the graphs are what you expect right there in the command line and get rid of it. Anyway, histograms are super important to data science because it lets you see your data at a glance. And we know that in Game of Thrones, according to this data set, most of the battles happen in the Riverlands. Some happen in the north, but it's pretty overwhelmingly in the Riverlands. And that was done using the go_num plot function. You just define your plot right here. You can use title. Title puts the title at the top. Y label is your y-axis. They equivalently have an X label for your x-axis. You can also put in, they're called keys. If you have a plot with lines, you can put a key in there and have them color-coded. They have lots of things that go with the plotter. You can also do points if you'd rather do values and stuff like that. It's quite, oh look, they saved it for us. It's quite thorough in its applications. That's what I'm trying to say. Any questions so far, Greg?
I've seen Go able to do the cleaning up of the data part too. Is that better? Do they have the normalization or like free-form text is asked to deal with?
Yes. I'm trying to think of what packages. I know that I'm pretty sure that if you want to normalize it, Go data frames, the Go to data frames has a normalization package just with that. I know that, I'm pretty sure that the SG Whitworth Golang has some tools for that as well. I actually have used, there was another package I used in one of my things. I don't know if that had normalization in it, but we can see. It's this one. This one is natural language processing done not in a notebook, but I use this for my natural language processing, and I don't remember, I'm pretty sure they had a normalization on it as well, so you can get everything to one. They have, so this one I really like. I wasn't going to get into it, but we can. So natural language processing is one of the easiest things to get into as far as what your AI is, right? Because it just compares text. This was actually my first venture into data science. So what this does is it converts a string of text into a vector, and it just does simple vector operations on them. It can subtract them, it can do cosine operations on them, it can do a whole bunch of things. There's several distances that uses for comparison in this model. There have the Jaro-Winkler distance, the Hamming distance, the Wagner-Fisher distance that I've used, and these just basically tell you the similarity between the vectors. So if you get, I'm pretty sure with that the closer you get to one, the more alike they are. And you can actually, with these, you can set weights. So if you give it multiple strings to compare, you can attach a weight to the string. It's actually pretty cool. The Sajari word2vec also does the same, has comparisons, and it has cosine length, and a couple other different vector models for comparing strings. But with that, you can also normalize them and do different things to that. So Go does have a lot of tools for cleaning up data. There's a lot that can be improved. They're constantly looking for what. The more you use it, the more you figure out what the bugs are. So the more that these libraries get used, the more pull requests they get added to them, the better they'll be, and the quicker they'll be, like pandas and NumPy and SciPy, which are kind of the top dogs right now. So yeah, there's quite a bit there. I was gonna go to a different example. Did I look through these ones? No. We'll go to example number 2 because that one had other pretty things. Oh, this one was linear regression. I love linear regression because they put a really fancy name on something that we all learned in seventh or 8th grade, which was line of best fit. You plot some points and see what line goes up the middle. Like, we all learned how to do that before we learned how to do anything else. And now they're making it sound fancy by giving it a long name like linear regression and doing it to hundreds of points. Like, I'm pretty sure that was one of the first programs I wrote when as a physicist. But linear regression is super common in machine learning. It's like what you do. Well, that's not true. What's it called? The MNIST handwriting samples are what you do. This is just the basic step before that. Yeah, you're halfway there if you can draw a line in between points. But all of the books that I've read on machine learning, like, they talk about machine learning. It's actually really common to use because all kinds of fit ends up being linear fit. Even if your data has a logarithmic shape to it or quadratic fit to it, you can normalize your data in such a way that it stays linear. So the power of linear regression is incredible. It's just also really simple to implement, which is why it's so commonly used. And another reason why anyone can do it, right? Anyone can understand it, anyone can implement it. If you want to find trends in your data at a massive scale, you just need a couple engineers and a couple good packages, and you can see a lot of information from it. So I don't want to undersell the value of linear regression. It's just, I find it funny that that it's just drawing a line between points. So this one, what did they say this data set was? Basketball height and weight? Well, we'll print it out and see, right? Because we got a data frame that we're printing right here. So we got baseball players, their height and their weight, and it has their age hidden off to the side. So that's pretty cool. We can get rid of the names because we want to anonymize it and just see. Somebody apparently weighs nothing. That poor baseball player must not do very well. How would that work physically? If he weighed nothing and he hit the ball, would that energy be, all of the energy would be completely translated into speed at that collision. So that would be a very interesting physics problem to work out. He'd have to be doing something about the speed of light. It's the only way it would work. Right? Reasons why data needs to be cleaned is because we know that that person does not exist. But sometimes you do need zeros. For example, we at work we're trying to do forecasting. Forecasting is another common use for machine learning. We're trying to do forecasting of banking trends off of banking account data, and knowing moments when the balance is zero seems to throw off the data, but it's vital that you know when an amount is zero or approximately zero, even if it throws off your forecasting model. So sometimes the zero is super important, even if its weight can be appears to affect it negatively. So don't always throw out zeros. Is this one going to show it? So we have a histogram. It's very common when you're trying to figure out what your data is to always view a histogram first, because it's an easy way to see it without staring at your SQL equivalent of it or your data frame and making assumptions. It's just quick and easy. You can get your mean, in your standard ranges visually without having to see anything else. What's the difference between these two? Oh, one is for, they're both height. Oh, yeah, I don't know what the difference between those two. Oh, this one is for age, that's nice. I want to see clustering. Oh, this is linear regression, so we're going to find a trend. There we go. So now, see how beautiful that plot is? That's Golang for you. It makes pretty plots. You can get them in color. They're vectorized as opposed to, what is the other one? I forget what it's. Scalar? Yeah, it is. It is scalar. I knew that. And so the beauty of things being vectors is you can publish them easier, like not externally to like papers, but like if you want to write a blog post on it or a post on Medium about work you've been doing, you have beautiful things that you can throw up on any website screen, and you don't have to make it hard for anybody else. You had a question?
Yeah, it's more about the chart than it is about Go. Why?
Which is fine.
Why do the magenta circles instead of having points?
Why do the magenta circles instead of having points?
I mean, it looks cool. Yeah.
There's no real reason why the circle is better than a point.
Oh, okay.
You can change the style of it, I believe, somewhere. But a lot of times, especially if you do things in grayscale, the shapes do matter because you can differentiate different,
Density.
not different densities, but different groups
Oh.
based on the shape, right? If you have a triangle as opposed to a cross, as opposed to a hollow circle, you can easily differentiate that in grayscale.
Okay.
So shapes do matter, but if you're going to be doing all the same shape, dots are just as common as these circles. These would be really hard to see if they were yellow, so just be aware. Another thing, these are all things that I end up doing on my team. I'm trying to think of what if a data engineer would ever split the train test, but that's not the case. But a machine learning engineer would. So when you're training your model, it's very easy. It's very, not easy. It's necessary that you have a train set and a test set, because if you don't know if your model works, because it could overfit to your training set and like basically have a line that hits every point, and then you put it on a real life model and it's garbage. So having a test set just to make sure that your model makes sense is very common. Here, what they basically do is they see how long it is, and then they just set a point that's 4/5 of the way in, and then they just say, okay, this data set is the first half, this data set is the second half, and just split it in half. I know in pandas, there is, you can actually, you just say like 70-30, and it automatically does that for you, and it'll randomize it. So look, there's an idea for a pull request if anyone who wants to go into data set. Who is the data set is done by Golang? Who knows? Where was data set? Data set select. So data set is a data frame, and they're splitting it based on the data frame. So if anybody wants to go to data frame and add a pull request to make it nice and easy to split like pandas, there's your idea. So you split it into your train test, and then you print it. We'll need to split it, and then we'll just train our model and see what happens. So here they have they're using Golang linear regression. I didn't know Golang had a linear regression package. I've only ever used the S.J. Whitworth linear regression. They're Golang. So it just is a linear regression, does all of the heavy lifting for you. If you have your training set, put in your parameters that you want to match on, and just go, and it trains for you based on that. So here is our function for the line. So we can take that function, throw it back into the plot, and get it. So we have are, and this is the y equals mx plus b that we learned just after we learned how to draw the line between the points. We learned what the line meant. So you have your y-intercept at negative 136, and your x at your b, your rate at 4.9 to height. And what was our rate? So apparently, for this to be matched, we have to start at 0 height is negative 136 pounds. So we have antimatter somewhere for people of 0 height. So that also would be very interesting to see an antimatter being hitting a baseball of 0 height. Don't know quite how that one would work. And we can evaluate it and see how accurate it is. There are several ways that are common in machine learning for evaluation. If you're doing, it depends on what you're doing. For linear regression, the most common is your mean square root error. So you just take your line, the distance the training point is from the line, you take the square root of that, you sum them all together and average them, and that's your mean square root error. So we got 17, which isn't really that bad. What was our standard deviation according to the data set? Was 2.3 of the weight, which is what we care about. The standard deviation was 21. So the fact that our error was less than our standard deviation means it was successful. So that's a good model. We can throw it up there, put it in a notebook and deploy it and say, we can now model baseball players' height and weight. So that was pretty simple, straightforward. Yeah?
Are you using any of these in production as opposed to some other kind of prepackaged machine learning tool sets?
Am I using, so the only thing that I'm using in production is I use the S-metrics package for natural language processing, just to basic comparison of business information, right? So we have a business name, street address, phone number, all that stuff. I compare a bureau reported one with a customer one. We do vector operations on it and give a score based on that. That's the only thing we have running in Go in production right now. Mostly because everything else was written in Python, and we run everything off a SageMaker, which doesn't have a Go integration. As soon as I deploy the Go integration to it, there's nothing stopping me from writing Go in production. But that's the only thing I have. I do know that other people do have Go models running in production, but I will say that Python is the most common. Python or Scala are the most common machine learning production models right now. So I only have a little bit running in production, but we'll get there. I keep working on personal stuff, but that gets interrupted by work, you know. And my dog is very needy. You saw the pictures, he's adorable. And every time I sit down to work, he either wants the food I have or to type on my keyboard, and none of those help me get stuff done. So, yeah. I have 10 minutes left to present. I could go through another model, or if anybody has any burning questions about machine learning or getting into data science or how it can be useful, or data engineering or anything I didn't cover, we can do that.
So you're using both Python and linear preferences. So where do you assess the state of tools that want to use years before they some kind of parity, or there's sufficient enough parity to more likely to choose to go. Python and Go.
No. You're definitely right. I'm just trying to think of how to answer this question. I think, first of all, it depends on the use case. I think that, like, for linear regression or other simple, your natural language processing, The Go libraries are very much well established and can go ahead and be done. I haven't messed around with Gorgonia for neural networks in Go. I haven't messed around with a lot of neural networks. The neural network model I have helped work on, we've implemented in Python. But I honestly think that the only thing that's stopping Go from being used more is just the fact that it is not the systems that it runs on. At my work currently, we don't have any local GPUs that we can use. We do everything on AWS, so we use AWS's machine learning tools with the SageMaker, which naturally runs with Anaconda Python on it, and you can install TensorFlow, and it has what do you call them? Life cycles that set up your environment and stuff. So it can be set up for Go. It just takes extra work when Python's prepackaged and ready to go. But if you have an entire ecosystem in Go and everything else you have ready to go, I think the Go machine learning tools are well enough established that you can implement simple models in Go and get them working. It's when they get more complicated that the tooling kind of gets harder. And I don't know if that's Go itself, if it's testing on notebooks, if it's establishing the model, if it's the package back to date, that's just where things lean back. But I think that the more people that start using Go for machine learning, the quicker that the packages will catch up. Other thoughts? Taylor?
What's the advantage of using one of these libraries for data frames? Teach your basic data out compared to using something like SQL that has to fit them.
The advantage to using data frames is for machine learning. You can, with the data frames package, they have things built in that allow you to like your train test split or your divisions into things that are easy to run a model against. Can you do that with SQL? Yeah, just build a for loop and do it yourself. It's just they already have that built in. Sometimes data frames are really easy to read. I can print that out in a notebook, and it's visually nice for me to see in a nice matrix. I'd have to open up the database. You can use a tool for that to see it that way. But I do both on a regular basis. In Python, it's very common to use data frames because it's already part of pandas, and pandas does the splits for you. Pandas sets everything up and ready to go. With Go, because data frames are newer, there's no reason why you can't go ahead and use the SQL or JSON integration to get your data the way you want. Whatever's the most comfortable for you, you just have to get it ready to pump into your model. And each model is set up its own way, so you can do it however you want. Other thoughts? Ooh. 6 minutes left. What to do? I know what to do. I was going to do this, but I forgot. I was going to show you the Gopher data page. Just because they have everything there, and they have a blog. If you're interested in all in data science, they have a channel on the Gopher Slack that they post on almost as much as as Derek posts on the gRPC channel, because he posts on that a lot. So they're pretty active on there for both Gonum, the Apache Arrow updates, and Gorgonia updates. And their GitHub's actually really nice. If you want to ever use a notebook, you need the Gopher Notes wrapper. It's really easy to install and use, and then you can spin up Jupyter notebooks locally. My binder in Go, that's what I use to launch those things today. Like I said, it uses a Jupyter Hub Docker instance based on your GitLab file. To use Go, you do have to add a couple of extra, what do you call them? environment settings or initiation settings so that it has the Go kernel in addition to the Python. But it's really nice to use. And they used to have, whatchamacallit, GoNum here, but now GoNum's its own thing. Another thing that has a lot of math tools is the GoHep library. I believe it's called GoHep. Is it not called GoHep? I thought it was. They have a lot of, yeah, it is. GoHep is used mostly in physics, but they have tensors, manipulation, their matrix manipulation, just a whole bunch of math operations. If you get into anything super complex that GoNum can't handle, this is your next step up in Go. Oh, and it has the Go binder implementation for that. And the one thing that we didn't talk about that's actually really big is Gorgonia. In GitHub. So this one is the D for neural networks, right? Neural networks are now the thing. Deep learning is the thing. The reason neural networks are nice is because it does more than one fit. So imagine your linear regression, you have one line. What deep learning does is it takes that line and then runs a whole bunch of different operations on it to edit your line so that it then says, oh, I don't want a line, I want a curve. Oh, I want a log. And it figures it out on its own using different formulas and analyses on it and hyperparameters and hidden variables and a whole bunch of other smart jazz that I'm still learning about. I have a whole book. But this is the Go implementation for neural networks and deep learning. It's the only one I know about, and it's thoroughly vetted. As you can, they have more likes than GoNum does, more stars. So if you did want to get a neural network running in production Go, this is your library for it. So if there's nothing else, then I think I will go ahead and end. I have right here, I like to publish my slides after, so I have all of the links up there to everything that I've referenced today, so you can check it out later if you want. But yeah, that's all I got today.